think so.
We can go over it. Let me pull it up.
Yeah.
Why is this guy waiting?
Okay. All right, let me share the screen here. Share screen. Boom, boom. All right, this is it right here, right?
Mm-hmm.
All right, so you want to go through these questions?
Yes.
Okay, if a radius of a unit circle is rotated to an angle of 4 pi over 3, what are the coordinates of the point on the circle at the end of the radius? Justify your answer with a diagram. Okay, 4 pi over 3. Okay, 4 pi. All right, let's go to the whiteboard. 4 pi over 3. All right, there's the whiteboard. Okay, so let's just make a quick sketch. There's your X. There's your Y. 4 pi over 3 is, let me check. 4 pi over 3 is in quadrant
He kind of just
3.
wrong for some reason, and I got this right because my answer is on the side. He put the answer
4 pi
there.
over 3, negative half, comma, negative 3 pi over 2. Okay. Now she said plus half.
No, he said I only got half the question right, which I don't understand because I put -1/2 and -√3/2, and that's what he put the answer as. But
Okay, so maybe, yeah, you missed the diagram. Justify your answer with the diagram. Okay, so maybe that's why he only gave you half credit.
okay,
Saying you don't have the diagram. All right, let me just confirm. 3 pi over 2, or no, was it 4 pi? Was it 4 pi over? 4 pi over 3. 4 pi over 3 is in quadrant. Let me share it. Can you see this diagram right here?
yes,
Okay, so 4 pi over 3 is in what? Oops. Can I make this the whole screen? How do I make this the whole screen? All right. 4 pi over 3 is in quadrant 3. Okay, I know why he gave you only half. Couple things. It's in quadrant 3. It's 240 degrees, which is quadrant 3. So let's go back to the diagram. Let's see here. All right, so I'm just going to make a quick sketch of this. Your 4 pi over 3 is somewhere right here. This is your 4 pi over 3. 4 pi over 3. So it's kind of like this. All this up until right there.
Mhm.
So here's your radius. And you had the right coordinates. It was, what was it again? -1/2?
-1/2 and -√3/2.
-√3/2. So yeah, a couple things. This is quadrant 3. That's quadrant 3, Q3. And the diagram. So it's just the rough sketch of the diagram. So something like that. Okay. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so I think that's why he gave you only half. All right, next one.
This.
Our next one is where did I put that sheet? Okay, so yeah, quadrant 3. Okay, number 2. Which angle on the unit circle produces coordinates of that? You can give your answer in radians or degrees. Okay, so you said 135. All right, if we go to the unit circle diagram, which is this, let me pull up the whole screen. How can I, let me go back. Let me go back. Oh, visit page maybe, visit site. Where are we? This one. Let me go the whole screen. All right, let me just find the right diagram so we can look at it together. Maybe this one. pages, image sizes, visit site, visit site. View image, that's the one. Okay, here we go. All right, what's the coordinate? The coordinates is
Negative √2/2 and negative. I mean, wait, negative
positive.
√2 and positive 2
Okay.
√2.
So you're saying 135. Let's go to the diagram and check. 135, yes. So yeah, you gave it in degrees. Yeah, that one's good. So it's really in radian, it's 3 pi over 4.
Oh, over 4. Okay, I put
Yeah,
over
but
4.
it said you can give in degrees or radians. So you're good on
Yeah.
that one. You're good on that one. Next question. Oh, that was 2. Okay, so she gave you full marks for 2. Okay. Number 3, evaluate each of the following. Sine 5 pi over 3. So for the sines, it'll be the y value. And on cos, for like question B, it'll be the x value. And then tan, which value is it for the tan? You know what I mean?
Yeah, I know. I don't know how to do tan at all.
All right, okay, we'll do that one when we get to that one. Okay, 5 pi over 3. What angle is 5 pi over 3? Where's my diagram? Okay,
Oh.
so you see this unit circle here, right?
Yeah, it's 300 degrees. And
Yes.
√3/2 and 1/2.
Okay, so which one is it? Is it the half or is it the negative 3 root pi over 2?
And a 1/2.
It's the sine value, so it'll be the y value.
So 1/2.
Not the x value, the y value. Negative root 3 over 2.
That one's the x for this one. Oh wait, did I do this wrong? Wait, hold on.
You put negative root 2 over 2. So let me write it on the screen. Can I write it on the screen or no? Maybe I can write it on this screen. Can I write it on this screen? Oh, what happened here?
I might have wrote my units wrong.
It's the y value of 300 or 5. See my mouse? Can you see my mouse?
All I see is you right now.
It's the y value, negative root 3 over 2. The sines will be the y value, the coses will be the x value. You get it?
Yeah.
So for number 3A, what's the answer for 3A?
√3/2.
Negative root 3 over 2.
Negative √3/2.
Okay, so for B is cosine 3 pi over 4. Now that one will be the y value. So it looks like you got that one. Root 3 pi over 4. Which one is that? Root 3 pi over 4 is 135. So that'll be the x value since it's cosine. So for that one, it's negative root 2 over 2. You got that one right. Okay, for the tan, let's do the tan together. That is tan 1/3 pi. 10 pi over 3. All right, let's go to the whiteboard for that one. This is what, 3C? So for 3C, it's 10, it said 10 pi over 3, right?
Yes.
Okay, so for the 10, it'll be the cos pi over 3 over the sine pi over 3. So basically it's the x value over the y value. What's the x value?
For pi over 3.
Pi over 3, look at the y value. What is that?
3/2.
3 over 2, and then look at the look at the y value.
Oh wait, no. The first one's 1/2, sorry.
The x value is 1/2?
Mm-hmm.
Okay. And then the y
value? √3/2.
3 over 2. You see what I'm writing, right?
Mm-hmm.
Okay, now just simplify this. This is the same thing as half times the reciprocal of this one. 2 over root 3. All right, let me check that. We're talking pi over 3, which is 60 degrees. Pi over 3. Cos will be the x value, root 3 over 2. No, I'm looking at the wrong one. It's the root 3 over 2. No, half over root 3 over 2. Half. Yeah, that's right. Okay, so the 2's will cancel here. So you got 1 over root 3. Now, they want you to rationalize the denominator. Remember how to do that?
No.
Multiply. Okay, so are you with me? 1 over root 3. Do you understand up to that step?
Yeah. Yeah, I get that.
Just multiply the top and bottom there by root 3.
Okay.
So multiply that by root 3 over root 3. And what is that simplified? Root 3 over, what's root 3 times root 3? 3. So here's here's your final answer right here. Root 3 over 3. Just take your x value and divide it by the y value. Get it?
Yeah. Okay. So cos over sine.
Yeah, exactly. The x value divided by the y value, and then simplify.
Okay.
So on this step, half divided by root 3 over 2 is the same thing as half times the reciprocal of root 3 over 2, which is 2 over root 3. The 2's will cancel, so you get 1 over root 3. And then multiply the top and bottom of that by root 3. You'll get root 3 over 3. That's 3c. Okay, that's 3c. Next one. Next one is, okay, so you're good. 1, 2, 3, you're good?
Mhm.
Any questions on that?
No.
If I'm going too fast, just stop me, right?
Okay.
Number 4, given the graph below, fill in the rest of the angles on the available marks of the x-axis. Hint, leave off the quarter pi angles. Okay, so step A, they just want you to put in the what do you call it? Put in the radians.
Okay.
So they give you the half, they give you the 1, they give you the 1.5. So you filled in the pi over 6, pi over 3, you filled in the pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, and the rest of them. Okay, so A you got right. A looks good. On B, she's saying graph cos x on the interval. Okay. The only different, okay, let's go to the whiteboard. Okay, so I'm gonna sketch this. I'm gonna sketch the cosine graph. There's your y. Here's your x. All right. I'm just gonna do this. There's your pi. There's 1, 2, 3, 4, 5, 6, 7, 8. How many do you have? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 ticks on the 1, 2, 3, 4, 5, 6, 7, 8. 4 more. 9, 10, 11, 12. Okay, so that one's 2 pi. The 6th one will be pi. 1, 2, 3, 4, 5, 6. This one's pi. And then what else are they telling you? They're telling you that the third one is pi over 2. Third one is pi over 2. And then the 1, 2, 3 would be 1.5 pi. So this one is 1.5 pi. 3 over 2 pi. Okay, you see my diagram, right?
Yes.
Okay, so cosine starts at 0, 1. So draw a dot there. Draw a dot here. Draw a dot, and then this is negative 1 down here. Negative 1. Oops. If I extend that, we'll have our -1 down here somewhere. So just draw the key points. 1, 0, 1. This is pi over 2, 0. This one will be pi -1. This one will be right at 0 there. And then I believe this one's up here back at 1. So just sketch it. So it's like this. Down there to the bottom, through there, like that.
Okay.
So what did you do? So see where she put this arrow, this red arrow right here? She's saying this dot should be at 0.
Yeah.
And then you got it at half. Okay, so see this dot right here that you have at pi -1/2? That should be at pi -1. This should be all the way down here.
Okay.
And then the 1.5 pi should be at 0. And then the 2 pi should be at 1. So let's just confirm that with a Google search. If I go cosine x graph, cos x graph, you'll see what I'm talking about. All right, see this one right here? Can you see my screen there?
The whiteboard?
Oh, you see the whiteboard. Huh? Actually, let me share this one. All right, see this one right here? See the blue? You start at 0, 1. Then at I think this was, what was this one? This one was pi over 2, you're at 0. So pi over 2, you're at 0. Then at pi, you're at -1. And then, oh no, wait a second. I think I messed that up. At pi, you're at -1. -1. Is that what we drew on the whiteboard?
Yeah.
I'm having trouble switching back and forth, keeping this straight. Where's the whiteboard? Share whiteboard. Whiteboard. Oh, that's the wrong whiteboard. Okay. Actually, I'm gonna see if I can just draw it on your just take the graph that you drew, take that dot at half, I mean pi over 2 half, put that at 0.
Okay.
All right, let me what's going on here? So there's 1, 2, 3, 4, 5 key points. There's 5 key points, right?
Yeah.
So once you have those 5 key points, then just sketch it from there.
Okay, where does 3 pi over 2? What is that one at?
I think that one's 0. Yeah, see the blue, do you see this blue diagram right here?
No, I see you.
Okay, hold on, let me share that. Here it is. There's your key points. 0, 1 is your first key point.
Mhm.
Pi over 2, 0 is your second key point.
Mhm.
Pi, comma, -1 is your third key point.
Mhm.
3 pi over 2, 0 is your fourth key point. And then
2 pi 1.
0, 1 is your last key point.
Yeah.
All right. Or we can just go to Desmos. Let me go to Desmos. Desmos graphing. Graphing calculator. Y equals cos x. Okay, see right here? Let me change this to, let me see if I can change this to radians. Can I change it to radians? Degrees, radians, degree, radians. How do I change this to radians? All right, you can see Desmos, right?
Mhm.
Okay, so I don't know how to change it to radians, but look, here's your first key point, your second key point, third key point, fourth, and fifth. So this is your 2 pi. This one's your 2 pi.
Mhm.
This one is your 1.5 pi. 3, there's your 1.5. This one is your pi. This one is your 0. This is your 1 right here. This is your -1. And this one is your pi over 2. There's your 5 key points. So now just sketch it like that. 1, 2, 3, 4, 5, something like that. Okay. So it starts at 0, 1 and it ends at 0, 1. So it's a graph like this.
Okay.
All right. So that it has that general shape. All right, let's go back to your handout. That's for 4A and 4B. All right, 5. Based on what you have learned about trig ratios, find the length of missing sides on each triangle below. Okay, so they want you to find the vertical and the hypotenuse on that one, right?
Yeah.
Okay, let's go to the whiteboard for that one. They give you the bottom length is 6. They give you the bottom right angle as 45. Okay, so let's go to the whiteboard on that one. Whiteboard. All right, let's go here. Oh, this is the whiteboard I was looking for. Okay, so there's your rough sketch of the graph we were just talking about a minute ago. Okay, so let's draw your triangle. It's like this. It's like this, right? There's your 45. There's your 90. There's your 6. There's your X and there's your Y. Okay, how are we gonna find X? How are we gonna find Y? Using trig ratios.
I did.
Use the 45 somehow. Use the 45 and use your SOHCAHTOA.
So when you want the answer you want should go on the top, right?
Not necessarily. You could just set up a ratio that makes sense. It doesn't have to be on the top or bottom.
Okay, so could you do cosine for this one?
Cosine what? 45?
Mhm.
Okay, so cos 45 would equal what? Adjacent over hypotenuse, right? Adjacent over hypotenuse, right?
Yeah, so do we have to use sine? Because
Well, let's see. We know cosine is adjacent over hypotenuse, right? Sine is opposite over hypotenuse, and 10 is O over H, right? Okay, what's this ratio right here? Cos 45 would equal what? What's adjacent? What's hypotenuse?
we don't have either one.
We have adjacent. 6.
Oh wait, is the bottom's adjacent?
Yes. We're talking about this
Oh.
45. We're talking about this 45 degrees. Yes. Yep.
So adjacent means the one next to the angle?
Beside. Yep, exactly. Beside. Adjacent just means beside.
Oh, okay.
So this will be what?
So that would be 6.
Over hypotenuse, right?
Yeah.
Okay, now we can, this is still cos 45, right? Cos 45. So what's hypotenuse here? Hypotenuse would equal what? Hypotenuse. Hypotenuse would equal 6 divided by cos 45. You see why? Just cross multiply.
Yeah, okay.
And what does that work out to? Can you do that on the calculator?
Yeah.
So hypotenuse equals what?
One second, I'm trying to.
Cos 45 is what? I forget off the top of my head.
45.
Oh, leave it in radians. Leave it in terms of pi. What's cos 45? Look up on your unit circle diagram. The x value of 45 degrees.
Root 2 over 2.
Root 2 over 2. Root 2 over 2. Actually, let's do one more step here. Let's do one more step. Let me go just double check that. Where's my unit circle? Okay, so 45 is, yes, root 2 over 2, that's right. So take your root 2 over 2 and multiply by 6. So this is the same thing as hypotenuse equals, what was it again? It was 6 divided by root 2 over 2, right?
Yeah.
What's that the same as? That's the same as 6 times 2 over root 2, right?
Yeah.
And that's the same thing as 12 over root 2, right?
Mhm.
Now, how do you rationalize the denominator? Just multiply the top and bottom by root 2.
Well, yeah.
All right, so let's do that. If we multiply that by root 2 and that by root 2, what does it equal? 12 root 2 over 2,
2.
which is the same thing as what? 12 divided by 2 is 6 root 2, right?
Root 2. Yeah.
So that's your hypotenuse.
Okay.
Hypotenuse is that. And now, how can we find the x? How can we find x? This vertical distance right here. We know hypotenuse is 6 root 2. So this is 6.
So do we do sine now?
Just tell me yeah, it doesn't matter which one. As long as the ratio makes sense, you can find a different way. So what's the sine ratio?
Sine 45.
Sine 45 equals
Uh,
opposite over hypotenuse.
Yeah, so 6 over 6 root 2.
Opposite would be opposite would be 6. Hypotenuse would be 6 root 2. 6 root 2. The 6's will cancel. Right? So sine 45. Actually, I missed one. No. Now we're talking about this 45 now, right? This one on top here.
Mhm.
So that it won't be sine. It won't be sine. Opposite will be 6 and the hypotenuse will be 6 root 2. So it'll be cosine 45.
Okay.
Because we want to use adjacent. The adjacent side is x. So this will be cos right here. And that'll be adjacent. So cos 45 is adjacent over hypotenuse. And adjacent is x in this case. All right, so let's do it. Adjacent is the x. X is what we're trying to find. Cos 45 is just cos 45. And then the hypotenuse is 6 root 2. 6 root 2. All right, so x is equal to what? Just cross multiply.
Cos 45 times 6 root 2.
And what's cos 45?
Root 2 over 2.
Root 2 over 2. Now just simplify that, what I wrote right there. X equals what?
The 2's would cancel, right?
The root 2's on top would just change to 6 times 2 over 2.
So then 12 over 2, which equals 6.
Which is 6. There you go. There's your two answers. The vertical distance is 6, and your hypotenuse is 6 root 2. So this answer right here, and this answer right here.
Okay.
All right. Any questions on that one?
No.
There's the whole thing right there. So maybe take a picture or just copy that down.
Okay.
All right. Next one is
I got the next one right, and the last one I got half.
all right. You want to skip B then? You're good on B?
Yeah, I'm good on B.
All right. Next one is 30 in the bottom right, and 9 is the hypotenuse. Okay. 30 and the hypotenuse is 9. Okay. Here's our triangle right here. Here's our triangle. We have 30 right here. This is 90. This is 9. So what does this angle have to be right here?
60.
Yeah, okay, good. All right, now what are we trying to find? We're trying to find the x there, and we're trying to find the y here, right? All right, just set up a trig ratio that makes sense.
So we have the hypotenuse. So
Use one that has h in it. We have the hypotenuse, right? 9. So either use sine or cosine.
so cosine 60.
Cos 60 equals adjacent over hypotenuse, right?
Yeah.
All right, adjacent over hypotenuse. We know would the y be the adjacent or would the x be the adjacent to 60?
The y would be the adjacent.
Yes, exactly. So y over 9, right?
Yes.
So y equals cos 60 times 9. Just tell me what cos 60 is again.
Oh, cos is x, right?
Yes. Yep.
So
X value of the 60.
So 1/2.
And then, so that's not half times 9, right?
So
Just leave it as 9 over 2. Y equals 9 over
okay.
2. 4.5, right? 4.5. There's your 4.5.
Yeah.
Okay, so now we have the y. How do we find the x?
Okay, so I got that one right. I did the 4.5. It was the bottom one, I think, right?
Oh, all right. Let me take a look at what you got. Okay, yeah.
But I did sine 30 instead of cos.
Okay. Okay, got you.
So I think that was what I got wrong.
Okay. All right, just set up another ratio, or use you could use your Pythagorean theorem. It's probably quicker to use a trig ratio. If we say sine, what did you say? Say sine 30? Sine 30 would be opposite over hypotenuse, right? We just calculated the opposite. Actually, no. Don't use sine 30. Why can't we use sine 30?
Because the opposite would be 4.5.
Yes. Basically, we have to solve for x there. So let's use cos 30. That would be adjacent over hypotenuse. Use cos 30 right here. Eraser cos 30. So cos 30 would be equal adjacent over hypotenuse, right?
Yep.
And what's adjacent?
So the adjacent is one we don't know.
To the 30. What's the side beside the 30?
Y. Or wait, no, x.
X, yep. So x over 9. The hypotenuse is given as 9. Therefore, x equals cos 30 times 9.
Which is root 3 over 2.
Okay, so now that's cos 30 is root 3 over 2.
Yeah.
And then multiply that by 9. How do we simplify that? 9 root 3 over 2. That's what x is. So there's your two answers. Okay. It's just a matter of setting up the right trig ratio. Nine over 2 root 3. Cos 30 is adjacent, which is x, over hypotenuse, which is 9. X would equal cos 30 times 9, which is root 3 over 2 times 9, which is 9 over 2 root 3. Cos 30. What's cos 30? Cos 30 is the x value on 30. Root 3 over 2. Yes, yep. You good on that one?
Yeah.
I think you use sine on that one, right? Sine 30?
Yeah.
Yes. All right, you got anything else you want to go over?
Oh,
When was that quiz? Last week?
Yeah, it was last week. I'm gonna retake it.
Oh, she gives you the makeup chance to make up.
Mhm.
Okay. Got any homework questions you want to go over?
Um, give us one more.
Or maybe I'll just look up some more like the ones on the bottom there.
Okay.
Trig problems worksheet. All right, so something like this. All right, let me share this screen right here. Share screen that. Okay, can you see this worksheet right here, this handout? These are ones like the ones that are on the bottom of that worksheet we just did. All right, so say for number 5, how do we solve for y?
Um,
Use this angle right here, the 15. What side is y in relation to the 15?
uh, opposite.
Okay, so we have the opposite, or like we're looking for that. What side is the 38 in relation to the 15?
Adjacent.
Okay, so we have opposite and adjacent. Which trig ratio are we going to use?
Tangent.
Exactly. So tell me what to write.
So 15
Equals
y over 38.
38. Yep. Okay. And then y equals, what's y equal to?
Uh, 10, 15
Times
over, yeah, or times 38.
38. Yep. And then look on your unit circle diagram to tell me what 10, 15 equals. Or what, tell me what the cos is, tell me what the sine is, and then we'll divide it.
Mine goes from 0 to 30.
Probably doesn't even start till at 15. Yeah, you're right. Most of them start at 30, I think. But anyways, that's how you do it, right?
Mm-hmm.
All right, let's try another one. How about 9? No, how about 3?
So we need y. We need to find the opposite.
Well, they're asking you to find x on the bottom.
Oh, okay. So we need to find the adjacent. We don't have y either.
Okay, so
So
we're looking to find adjacent, and which
so
one? What else? What else? What's the 23?
hypotenuse. So cosine.
Exactly. So tell me what to write.
So cos 49.
Cos 49 equals.
X over 23.
There you go. So what does x equal?
Cos 49 times 23.
There you go. Cos 49 times 23. All right, what about 12?
We have the opposite. We need adjacent. We need adjacent and hypotenuse.
Which trig ratio?
Tangent.
Tell me what to write.
Tan 29.
And 29 equals opposite, which is 91.
91 over x.
X. So what does x equal? X equals
tan 20 over 91, right?
Or
91 over.
not, yeah, 91 on top. 91 over 1029. Okay. All right. Can you write on the screen? Are you able to write on the screen?
Let's see. Can you see this?
Yes, try 4, 7, 10.
Okay.
Yeah, exactly. So cos, yeah, cos
41
1 equals adjacent over hypotenuse.
equal x
There you
over
go. There
30.
we go. Yep. So x is what?
X would be cos 41 times 37.
See, there you go. It's just see what I mean. Why it's just a matter of setting up the right ratio, the right trig ratio. Once you set up the right trig ratio, the rest is just algebra, right? So everything is based off of this first line. You know what I mean?
Mm-hmm.
Everything is based off of that. Everything is based off of that. Everything is based off of that. You know what I mean? The rest is just algebra. So the
Yeah.
main thing is setting up that first right the right ratio basically. All right, 7 and 10.
So
If you could do it verbally, just tell me verbally 7 and 10.
okay, so we have opposite for number 7.
Yep. And
We need the adjacent and the hypotenuse. So
say,
you could do
say everything again.
so we have the opposite.
Yep.
We need the adjacent and the hypotenuse. So we could do
Well, okay,
sine.
hold on right there. Hold on. We have the opposite. What they're asking us to find, are they asking us to find the hypotenuse or the adjacent?
They're asking us to find the hypotenuse. So we could do sine.
So just tell me verbally what the ratio would be.
Sine 38 equals 15 over z.
Exactly. Yep.
And
So
then that equals sine 38. I
sine,
mean, that equals
sorry,
15 over sine 38.
sine 38 would be 15 over z, right? So
Mhm.
therefore z would equal 15 over sine 38. Is that what you said?
Yeah.
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 Okay. Yep. All right. 10.
So 10, we need to find the hypotenuse again.
Yep. And
And we
we
have
have the
adjacent.
right.
So we do cosine. So cos 38 equals 15 over
There you
w.
go. There you go. There you go. Yep. Exactly. Yeah. You understand it. You just need more reps. That's all.
Yeah.
That's all. So that's the idea. All right. Let me see here. Okay, so just remember the sign, like number 3 right here. Oh, actually, let me not even share the screen. Let me share I'm going back to that handout that you had.
Okay.
On questions like 3A, B, C, just remember sine's the y value, cos is the x value, and 10 is the y value over the x value. And what else do you have? 1 and 2 are you allowed to use the diagram on the quiz, the handout with the unit circle diagram?
So what he does, he'll give us like a blank one, and we just fill it out what we know.
Okay.
Like we can use it, but we just have to memorize it.
Oh, got you. Okay. Yeah, that you definitely need this because I don't remember all this stuff off the top of my head either. I need to look at these diagrams, those unit circle diagrams. Because I don't know what those ratios are at the top of my head. Unit circle diagram. Yeah, this is definitely helpful. Without that, it's hard for me to remember what's what. All right, what else you want to go over?
Let's see.
Or what are you guys doing this week in class?
We're doing like transformations.
Okay. You got any homework on that? Want to go over?
he didn't give us any homework, but we just had to do like if it was a cosine graph, it would be cos. Is it theta plus
Yeah.
1 or cos theta plus 3 or like sine theta plus 1? So like a regular graph,
Uh-huh.
but just trying to get the transformation part.
Okay. With Desmos right quick, so you get a visual idea of what we're talking about. It's basically the cos graph translated or the sine graph translated one way or another, up, down, left, right, something like that, or a combination of up, down, left, right.
Yeah.
All right, so there's your stat. Oh, let me share this. I'm not even sharing this. Share screen. Share that. Okay, there's your standard cosine graph. So tell me, you have one that in front of you, cosine, so we could give me one of the transformations that you guys are working on.
So one says f of theta equals cos of theta plus 1.
Put that down. Say it again.
F of theta equals cos theta plus 1.
Okay. See the plus one on the end?
Mhm.
Is that going to be one up, one down, one left, or one right? Okay, see these 5 key points right here?
Mhm.
1.1 is right there. 0.2 is right there. 0.3 is right there. 0.4 is right there. 0.5 is right there. Those are your 5 key points, right?
Mhm.
Are those 5 key points moving one up, one down, one left, or one right?
1 up.
Exactly. So this point, see my 5 key points there? I'm going to do the new points in red. There's your new key point 1. There's your new key point 2. There's your key point 3, new key point 3, new key point 4, new key point 5. Do you get it?
Yeah.
Now there's your new graph. Same graph, just everything is moved up 1 unit. Okay, so that's when the number's on the end. Now sometimes you'll have a number on the inside. Do you have one like that?
Yeah, like it will be like 2 cos theta plus 1. We did
No.
something like that, I think.
Okay, when the
Oh, you mean when it's like theta minus 2
yes.
or something?
Yeah,
Okay.
exactly.
Yep.
On the inside of the bracket. On the inside of the bracket. So basically, all I'm trying to say is you take that original graph, these original 5 key points, you're either going to move them up, down, left, right, or some combination of up, down, left, right. So let me go back here. Go back to the black. Okay, so I think if I'm trying to remember, if the general formula is f of theta equals a cos theta plus, I don't know, c or something. If the a value on the front of if the coefficient of the a value of the cosine, if this is like a fraction like less than 1, the graph will be condensed in the y direction. Basically, it's the original graph either stretched vertically, stretched horizontally, and then moved up, down, left, or right. Or some combination of up, down, left, right. So give me another one. I'll put it in Desmos and I'll show you.
We have f of theta equals cos of theta minus pi over 2.
Cos of theta. Do I have theta here? I even have theta. Oh, okay, let me write it down first.
Stop.
Tell me what the formula was again. F of theta.
F of theta equals cos of theta minus pi over 2.
Now is the minus pi over 2 on the inside of the bracket, or is it on the end?
The inside.
So is it like this, like I'm writing? Is that right? Pi over 2, like that?
Yeah.
Just like that. Okay. Okay. See, when the plus or minus whatever is on the inside of the bracket, that's going to be left or right.
Okay.
Okay. So your 5 key points, right? 1, key point 1, 2, 3, 4, 5. What are you going to do with those 5 key points? Are they moving pi over 2 to the right or pi over 2 to the left?
Pi over 2 to the it's minus, so is it to the left?
Yes. Yep. All right, let me show you on the Desmos because they can do graph it better than I can. You're going to say, I'm just going to use x. X minus pi over 2. Where's my pi? Do I have pi over here? It's basically those 5 key points shifted pi over 2 to the left.
Mm-hmm.
All right, I'm not sure how to. I'm messing up this Desmos, but I'll give you just a quick sketch. Take your key point 1, move it pi over 2 to the left. Take this one, move it over to the left. That one, move it over to the left. That one, move it over to the left. That one, move it over to the left. There's your new graph. Each of the 5 key points are just shifted to the left pi over 2 units.
Okay.
Now, if this was f of theta equals cos pi plus pi over 2 on the end like that, what does that graph look like?
It goes up pi over 2.
Exactly. There you go. There you go. All the take those 5 key points and just shift them up pi over 2. Yeah, exactly. Yeah. So just make a mental note. If it's on the inside, it's left or right. If it's on the end, it's either up or down.
Okay.
And then you might have something like this too. I think you were talking about this a minute ago. F of theta equals a cos something. Okay, cos theta. The a value, depending on what the a value is, if it's bigger than 1, it's going to be stretched. If it's smaller than 1, it's going to be compressed. You get what I mean?
Yeah. I'm writing it down.
If the a value is less than 1, like half, for example, or 1/3, it's going to be compressed. If it's bigger than 1, like say 5 or 7 or something, it's going to be extended. What's the right word? Expanded in that direction.
Okay.
So a few things could happen: compression or expansion, and then a shift either left or right, or a shift up or down, or all 3 at the same time.
Mhm.
Or one of those 3, 2 of those 3, or all 3 of those 3. It's basically you take that standard sine or cosine graph and do something to it. Translate it, compress it, shift it, something. Or even a combination of those things all at once. You all start off with these 5 key points. Just shift or move those, translate those 5 key points, and then there's your new graph.
Okay.
That's what you guys are studying this week?
Yeah.
All right, so you have a general idea of what you guys will be studying already. Anything else?
Nope.
And just remember, the cosine graph starts at 0, 1, and the sine graph starts at 0, 0. Actually, let me go back to Desmos just to give you an idea. Y equals sine x. Okay, see the red and the blue?
You're not sharing your screen.
Oh, my bad. Share. All right, see the red graph, the red and the blue graph?
Yeah.
All right, let's talk about the. All right, we kind of talked about the cosine graph already. The red, there's one key point, 2, 3, 4, and 5. Same thing with the blue graph. It starts at 0, 0. There's one key point, 2, 3, 4, 5, 5. So all you're doing is taking those 5 key points, depending on which graph it is, and moving those 5 key points up, down, left, or right, or compressing or expanding. So always start with the original graph.
Okay.
Always start with one of these two, the blue or the red, and then shift those 5 key points whatever direction, up or down or whatever. And that will be your new graph.
Okay.
Or you can kind of do it like one step at a time. Move it left or right, draw that new graph. Then move it up or down, then draw that new graph. So kind of do it step by step.
Mhm.
Any questions on that stuff?
No.
Anything else today?
No.
No? Look, it's just a matter of repetitions. The more 3-pointers you put up, the better you are, right?
Mhm.
Same thing with that math. The more questions you go through, the better your muscle memory. Right? There's a reason LeBron and Dame Lillard and Steph Curry. There's a reason them guys shoot hundreds of shots every day.
Yeah.
Right? It's automatic, right? Same thing with the math questions. Anything you want to be great in life, just put up the reps. Go through the repetitions, and you'll be fine. Right?
Yeah.
Are you good? Chloe, you good today?
Yes.
All right. We'll hopefully talk next week then.
Okay. We might actually talk at the end of this week. I'll tell my mom and let you know.
All right, cool.
Because I might retake more than one quiz.
Okay. Yeah. Yeah, just hit me up. Tell your mom to hit me up this week.
Okay.
All right. All right, peace.
Thank you.